We're going to go ahead and start the new section, which is topic 3. And in this topic, we're going to talk about linear systems. The first lesson that we're going to cover will be 3.2, which is solving systems algebraically. Now, please make sure that you're taking down your notes in your spiral, because remember, when it comes to test time, you're going to be able to use them on your test. So the first thing we need to understand is, what is a linear system? Well, a linear system is going to be a set of two or more equations, a set of two or more linear equations that use the same variables. So that means that at least you have the same variables, an x and a y. Make sure the other one has x and y. We cannot have one with x and y and then the other one with L and B or A and B or something like that. Now, there's two methods to do this. We could either solve it algebraically by substitution or by elimination. Today we're going to concentrate a little bit more on substitution, but I'm going to go ahead and briefly just explain both. So in substitution, what you're going to do is replace. Replace with something that is given. So you will replace with the given information. It's like when there's a substitute, like right now. I'm not there, but the sub takes my position as a teacher, and he or she is allowed to go ahead and write you up, send you to the nurse office, let you go to the restroom. They have my authority, the same authority that I do. Now, in elimination, what you do there is get rid of something. You get rid of whatever variable that they have in common exactly with the same. Same variable, same letter. So moving on to the first example, we're going to go ahead and look at example 1. We're going to give you two equations. So there's going to be 6 examples today. Now, when we look at that first one, we're going to go ahead and look at both of those equations and understand why I would start off with the second one. So when you substitute, it has to be equal to something. So in this case, we would start off with that second equation because it's already y equals. Now, what is y? X minus 1. So you should know that those two things are the same. So I'm going to go ahead and write down now the new equation, 2x minus 3. But instead of putting y, I'm going to substitute with whatever y is here, which in this case is x minus 1. And that right there is still equal to 1. So I'm going to go ahead and do the math. 2x, negative 3 times x is negative 3x. Negative 3 times a negative 1, it's a plus 3. And that right there is equal to a negative 1. So I look at the problem, and what can I combine? Obviously my x's. So 2 minus 3x is a negative 1x. We bring down that plus 3. And that right there is equal to a negative 1. So I'm trying to solve for x, so obviously I would have to leave the x here, but get rid of that plus 3. So how do you get rid of a plus 3? Subtract 3, subtract 3. Now my 3's there cancel. Negative 1x stays. Negative 1 minus 3, two negative numbers, you add them, you get a negative 4. But we're trying to solve for we're trying to solve for x, so x has to be positive. So now we have to divide by negative 1. So negative 4 divided by negative 1 would give you a positive 4. Now that you have this answer, you should be able to go and substitute it into the other equation that's in simplest form, which is the y equals x minus 1. So I go ahead and I substitute it into that one. So that problem right there is y equals x minus 1. I'm going to substitute the x. So I get 4 minus 1, and 4 minus 1 is 3. Now those two numbers together give me my order pair is the point of intersection of those two equations. So my answer would be an order pair x goes first, then my y. So it is 4, 3. Let's go ahead and look at a second example. So 3x minus y is equal to 5, and y equals 4x plus 2. So the one that's already solved for a variable is the second one, which is y equals 4x plus 2. So we're going to go ahead and take that 4x plus 2 and substitute it in for the y in the first equation. So 3x minus, in parentheses, 4x plus 2, and that is equal to 5. Now please keep in mind when you have that negative there, you have to distribute to everything in the parentheses. So that becomes 3x minus 4x minus 2 is equal to 5. I combine my variables, which in this case it's 3 minus 4x, it's a negative 1x, minus 2 is equal to 5. Then from here I have to solve for x, so I would have to add the 2 because it's a minus. That's negative 1x is equal to 7. Then I would have to divide by a negative 1, so x is a negative 7. So once you find one variable, you have to plug it into the other equation. The one that's in simplest form, which would be y equals 4x plus 2. Replace the x with a negative 7. So 4 times a negative 7 plus 2. So 4 times a negative 7, that would be negative 28 plus 2. That would give you a negative 26. Now those two answers together give you the solution to this linear system of linear equations, which would be negative 7, 20, negative 26. The third example, 3x plus 4y is equal to 12, 2x plus y is equal to 10. Now in this case, it's not solved for y, so or x, because it doesn't necessarily always have to be a y, it could be an x also. So you're going to go and look at those four numbers, the 3x, the 4y, the 2x, and the y, and decide which one has a 1 in front of it. So the one that does not have a number other than 1 would be the y. So I would have to solve for y there. So I'm going to rewrite the equation over here. So I would have to solve for y, so I would have to subtract 2x from both sides. So that gives me y is negative 2x plus 10. Now, since this is already y equals, then we do what we did in example 1 and 2. I'm going to substitute negative 2x plus 10 for the y in the other problem. So 3x plus 4, parentheses, negative 2x plus 10 is equal to 12. Now from here, distribute the 4. So 4 times the negative 2x is negative 8x. 4 times 10 is 40. And that right there is equal to 12. Combine my x's, 3 minus 8x. We subtract those, so we get a negative 5x. Plus 40 is equal to 12. So I'm having to solve for x, so I would have to get rid of that 40 because it's a plus. I would have to subtract. Now the negative 5x comes down. 12 minus 40 is negative, yes, negative 28. Then we would have to divide by a negative 5 on both sides. And for this problem, you're going to end up with a decimal. So if you haven't done so, hopefully you have a calculator just in case. But negative 28 divided by negative 5 would give me a 5.6. So in this case, we're going to have a decimal, and it's okay, nothing big. You have calculators. You should be able to do this. So now I have to plug in that 5.6 into the simple equation we have there. So y equals negative 2x plus 10. We're going to substitute the value of x with 5.6. So negative 2 times 5.6 would be a negative 11.2. The plus 10 comes down. Those numbers are different signs, so we have to subtract. So that's negative 1.2. So together, they're your answer. Example number 4. So this one's a little bit different. It's simpler. Every variable has a number. So my recommendation to you would have to be something that's going to divide nicely. So we cannot divide stuff by 3 in the second equation. So I wouldn't do that one, and we can't divide 3 by 2. So I would start off with the first one. Now the question is, who would you solve for? So let's try solving for y, since we're so used to doing that. If I solve for y, I have to divide by 4, and I end up with y is 2/4. In this case, 2/4 reduces to 1/2 x. Correct? But that's a fraction. Do we really want fractions? Not really, unless it's extremely necessary. How about we do it the other way? How about we get 4y is equal to 2x, but solve for x in this case. So if I solve for x, I would have to divide by 2, and I end up with 2y is equal to x. So I'm going to rewrite it, x equals 2y. That's a lot easier to work with. So 2y is going to be substituted for the x in that problem up there. So 3 times 2y plus 2y is equal to 2. 3 times 2, 6y, plus the 2y is equal to 2. Now 6 plus 2, well, that's 8y, is equal to 2. If I'm trying to solve for y, I would have to divide by 8. So y is 1/4 when it reduces. So 2 over 8 reduces to 1/4. So that's a y value. It's a fraction. Nothing crazy. This is like with the decimal. Plain and simple. You have a calculator to do the math for you. Now I'm going to go ahead and take this y is 1/4 and plug it into that simple equation. So I have x equals 2y. Well, that's 2 times 1/4. Now 2 times 1/4, please remember you only multiply the top one. This guy's over 1. And you multiply those two bottom ones. 2 times 1 is 2. And 1 times 2 is 4. So we get 2/4, which reduces to 1/2. So together, that x and y is 1/2, comma, 1/4. So example 5, we're almost done here. 2 more examples and we'll be completely done. In this one, they're not using X and Y, so we always put the letters the way they would show up in the alphabet. So M comes before N. Now, in this specific problem, if we look at the second equation, could 3 be divided by 2? Can 5 be divided by 2? More than likely, that's going to give me fractions. Let's look at the first one. Could 3 be divided by 3? Yes, divided by 3. Sure, 15 divided by 3, it does. So you always try to work with the one that's going to give you whole numbers, nice and pretty. So we're going to go ahead and take that first one and going to divide everything by 3 to simplify. So 3m divided by 3 would just be m. 3n divided by 3 would just be n. And 15 divided by 3 would be 5. Now, both of these letters have a 1 in front of it. So it really doesn't matter which one you solve for. You could solve for m or you could solve for n. In this case, I'm going to solve for m because it's the first variable. So I'm going to subtract n from both sides. That crosses out, so I end up with m equals 5 minus n. Or you could have put negative n plus 5. It's the same thing. Now that I have this, it's already set equal to each other. I'm going to substitute the m in the second equation with 5 minus n. So negative 2, we're going to put it in there. 5 minus n plus 3n equals a negative 5. We distribute the negative 2 to everything in the parentheses, so negative 2 times 5 is negative 10. Negative 2 times the negative n, two negatives become a positive, positive 2n. Bring down the rest of the problem. So now that I brought the rest of the problem, I need to make sure and I combine like terms. So 2 plus 3 is 5. N minus 10 equals to that negative 5. Now you're trying to solve for the variable that you have there, which is n, so I'm trying to leave it alone, so I need to get rid of that negative 10 by adding 10. So negative 5 plus 10 is 5. So 5n is equal to 5. We divide both sides by 5 and we figure out that n is 1. Now that I know this one, I go back and I substitute it into the simplified expression over here of m equals 5 minus n. So m equals 5 minus n is what? 1. So m equals 5 minus 1, 4. So together, when we write the answer, my answer should be 4, 1. Now please keep in mind what we said. Whichever letter shows up in the alphabet first, that's going to be your X or the first letter in the parentheses. So the last example is this one. Negative 7x minus 2y equals negative 13. X minus 2y is equal to 11. So go ahead and start working on it on your own. By the time you're done working with yours, this one's going to be working it out. And you'll be able to check your answer at the end. Make sure you're working on it. Don't just sit there and wait for this to give you the answer. You have to know you get this right before you get your assignment. So make sure you check your answer and see if this is what you got. Now make sure that you are working on this and not just sharing answers with your friends, because you guys need to know this, be able to work it out, all this work on the day of your test. Have a great day.